My name is Helga Stopper. I'm a professor for toxicology at the Institute of Pharmacology and Toxicology at the University of Würzburg, which is in Germany. And the title of this presentation is Pharmaceuticals in the Environment. I will provide some background information on the topic, and at 2 points of this presentation, you may take a break and do some internet research or study literature that I recommend to answer questions that I will state at these 2 points. Due to the widespread use of pharmaceuticals, their presence in the environment has become a significant issue with potential impacts on ecosystems and human health. Which types of pharmaceuticals are found in the environment? There are prescription drugs like antibiotics and antidepressants. These are drugs which are prescribed by healthcare professionals. Then there are over-the-counter medications like painkillers or antihistamines, which are available without a prescription. And then there are veterinary drugs, for example antibiotics and hormones, which are given to animals for disease protection or treatment and for growth promotion. But how do these pharmaceuticals enter the environment? Well, first of all, pharmaceutical manufacturing facilities may release pharmaceutical compounds and byproducts into the environment through wastewater discharges and air emissions. But then also pharmaceuticals are excreted by humans and animals after use, entering wastewater treatment systems or, in the case of animal manure, directly into the environment. And then improper disposal of unused or expired medications also contributes. For example, many people flush liquids down the toilet. This brings us to the first task. I would like you to get an idea about how many different pharmaceutical substances have been found in the environment so far. And I've given 2 sources where you can find approximate numbers of pharmaceuticals across the world. And I would like you to plan about 30 minutes for looking through these sources and getting some idea. Pharmaceutical residues occur globally in the environment. This is demonstrated in the updated database PharmsUBA. Residues of pharmaceuticals in the environment have been measured in 89 countries in all UN regions. For Germany, 414 active substances or their transformation products were reported, 749 for the European Union and 992 worldwide so far. In the graph shown here, you can get an idea about some of the compounds that are found quite often. There's diclofenac and ibuprofen right at the top. And on the right-hand corner, you have, for example, acetylsalicylic acid, which is aspirin, which you also probably all know. And in between these, you can find different examples for antibiotics, for hormones, for antidepressants, and different kinds of pharmaceuticals. Because pharmaceuticals are designed to have good stability, some pharmaceuticals can resist degradation and persist in the environment for long periods, leading to accumulation in soil, water, and sediment. Pharmaceuticals can be transported through water, soil, and air via various mechanisms such as runoff, leaching, and atmospheric deposition, resulting in widespread distribution. Some pharmaceuticals can undergo chemical transformations through processes such as photolysis, hydrolysis, and microbial degradation, leading to the formation of metabolites with different properties and environmental behaviors. So what can be the consequences on the ecosystems, and are there concerns for human health? Well, pharmaceuticals can impact aquatic organisms such as fish, invertebrates, and algae, leading to changes in behavior, physiology, and reproductive success. as well as alterations in community structure and ecosystem function. Pharmaceuticals can accumulate in the tissues of organisms and increase in concentration through the food chain, posing risks to higher food chain levels such as predatory fish or aquatic birds, and possibly to humans. Pharmaceuticals can also affect soil organisms and plant growth, with potential implications for ecosystems. Pharmaceuticals present in drinking water sources might pose risks to human health from chronic exposure via consumption of contaminated water. Swimmers, divers, or other recreational users of water contaminated with pharmaceuticals may experience acute or chronic health effects, including skin irritation, respiratory problems, and gastrointestinal symptoms. A first example that I would like to give is diclofenac. And diclofenac is really among those pharmaceuticals that are most frequently found in the environment. Diclofenac demand on the world market is huge. For example, in 2018, more than 2,000 tons were used worldwide. It is especially used against pain in the musculoskeletal system, and it's often applied as ointment or gel. However, if applied on the surface of the skin, only a few % of the active ingredient is taken up through the skin. Up to 95% remains unchanged on the skin and is later washed off, ending up in surface waters. A second example that I want to provide is gadolinium. Gadolinium-based contrast agents are used in MRI imaging, and they are not well removed by usual sewage treatment technology, so they end up in rivers. In this study on the left side, gadolinium in rivers of Tokyo was compared to previously reported values. The amount of gadolinium was changed depending on the location of the wastewater treatment plants, and the measurement showed increases in the range of 5-fold and more compared to 22 years ago. On the right side, the detection of gadolinium in tap water and tap water-based beverages is reported from Germany. The detected concentrations are not yet health-threatening as far as we know, and this is probably due for most or all pharmaceuticals detected in the environment so far. But if more and more is added, we may end up with critical conditions in the future. And I would like to point out briefly another problem that is associated with the use of pharmaceuticals, also only somewhat related to their presence in the environment. This is antimicrobial resistance. There's a 2022 paper in Lancet showing the global burden of antimicrobial resistance. And the data that they show are from 2019, and there were 4.95 million deaths from diseases in which antimicrobial resistance plays a role. 1.27 billion deaths were a direct result of resistance. Therefore, drug-resistant infections killed more people than HIV or AIDS or malaria. In Europe alone, more than 30,000 people die every year as a result of antibiotic resistance. And it has to be considered that most antibiotics, more than 70% worldwide, are not used to treat sick people, but they are used in animal husbandry. Resistant bacteria have even been found on vegetables now. And the causes are exhaust, air from stables, and manure in the fields. Elevated levels of antibiotics in surface water near urban centers, livestock farms, and wastewater treatment plants have been found, leading to concerns for the development of antibiotic-resistant bacteria and ecological effects of aquatic organisms. Therefore, also the problem is not caused predominantly by pharmaceuticals in the environment. The environment and our health are already affected by it as well. One thing that we can change relatively easily is the incorrect disposal of medication. Old or unused medications are often disposed of incorrectly by patients. For example, unused liquid medications are often disposed through the sink or toilet, but sewage plants are not equipped to eliminate them. Recommendations for safe disposal vary between countries. There may be return options or lists for specific procedures for some drugs. And I would like to encourage you to do task 1 at this point. And this would be to check recommendations for your own country. And maybe you can plan 30 minutes for internet research about how to best dispose old or unused medications in your area. So, what else can be done? Green pharmacy initiatives such as promoting environmentally friendly drug development are needed. Take-back programs are needed for medications, for unused and old medications, and education of the public regarding proper medical disposal. Sustainable prescribing guidelines would be good. Prescribing medications only if useful and needed, and then in small package sizes. Development and implementation of advanced treatment processes to remove pharmaceuticals from wastewater effluents and drinking water supplies would also mean great progress. The take-home messages from this lecture are the following. Pharmaceutical pollution has emerged as a significant environmental and public health concern due to the widespread use, the persistence, and the environmental fate of pharmaceuticals and their potential impacts on ecosystems and human health. Pharmaceutical pollution can lead to ecological disruption and may in the future cause human health effects. Addressing pharmaceutical pollution requires multifaceted approaches, including proper medical disposal, advanced treatment technologies, green pharmacy initiatives, education and awareness efforts, and research and innovation. And with this, I would like to thank you for participating in this activity.